Hello, grade 8s. You are stuck with me today. Cherubin was just getting so much fame and attention, and it was getting really hard for her to peek out her door at home. So we're giving her a little break from the limelight, and you're stuck with me today. So yeah. Plus, I need to talk to someone aside from the plant and my little kids, and that's you. So aren't you lucky? All right. So last day, you were introduced to your new unit, the water unit. And I guess it's nice to change gears. If some of you still have some outstanding assignments, though, please get in there and get them done so that we don't have to track you down. And this one is also, for this unit, you've had one lesson. You've had one very small Google assignment or Google form. And then today, I'm going to teach you this one, and then I'm going to do a little review of what you've learned in these two lessons, and then you're going to do an assessment, because essentially we'll be done after this lesson. We'll be done topic 1. So it's quick, it's short. Topic 2 is a lot bigger. But last day with Ms. Cherubin, you learned about water distribution. You learned some things like a lot of percentages, right? A lot of figuring out the breakdown of where water is on our planet. Like this, the fastest recap ever. Water is nicknamed the blue planet because from space, 74% of it looks blue because it's covered in water. Of that amount, 97% is salt water. Only 3% of all the water on the planet is fresh, and that's what we rely on. That's what many organisms rely on. And water management and figuring out where our water is, how to take care of it, becomes very important because of that. So most of the fresh water is tied up in glaciers and ice caps. There's a considerable amount found underground as well. And when it comes down to what's drinkable, what's potable, it's a very, very small amount, 0.03%, very small. So we're going to talk today about water quality. What is water quality? What could be in our water? What do we test it for? A couple of terms around the types of water we have, and then a few different methods of how to purify it. So let's begin. All right, so I can describe ways in which water can be tested and purified. Where do we get our drinking water from? How is it cleaned? We're looking at. So water is probably an underrated sort of concept or a topic around where we've grown up, because we're lucky enough to live in a country that is considered to be water rich. We have borders of oceans on 3 sides. We've got lots and lots of freshwater rivers and streams and lakes. In Alberta alone, we're considered to be a water-rich province because of that. So that's great for us. What kinds of things do we use water for? Well, we rely on it for drinking. We cook with it, clean our food, clean our everything pretty much. We play in it. So we fish, we boat, we use water for recreation. And then, of course, we're a cattle-rich, big agricultural province as well, so we use it for agriculture, whether it's watering our cattle or whether it's watering our crops. So Alberta uses water for many different things, and I'm sure you can come up with maybe 1 or 2 more. So we don't worry too much about our water. Other countries are not so lucky. So there are many, many people on Earth, 3 to 5 million a year, are dying from water-related issues. Maybe there's not enough clean water. Maybe the water that they do have is contaminated and has made them sick. So I know from looking at these pictures that there's not one sample here that I would want to put into my mouth or into the mouths of my kids. So water is a very, very important issue. What is water quality per se? The definition of water quality is how pure water is. How pure is it? What does that mean? Well, even if you take water from a brook, or it seems to be a beautiful clean lake, Water is never really pure. There's stuff in it. It could be natural salts. It could be minerals over the rocks and soils that it's traveled through. It's picking up minerals. There can be organisms in it. Organisms like bacteria, such as E. coli, for example. That one can really poison us and make us sick if there's an E. coli outbreak. There also could be parasites. So lots of different kinds of organisms. There's many aquatic organisms, right, that live in that water. There could also be organic matter. So substances that are just basically decaying in the water. So because of that, we test our water for a lot of things and make sure that it meets certain standards before it's put into the city reservoirs. One thing I want to talk about here is this one, the salts. Can you think of a word that refers to how much salt is in our water? Say salty water versus less salty water. It's a scale or a range. It has to do with the root word of saline, and it refers to how much salt there is in a given amount of water. So we would say the salinity of the oceans is much higher than the salinity of the lakes because they're only freshwater. And ocean salinity is only about 3.5% salt. That doesn't sound like very much, but if you've ever swam in an ocean environment, you can taste that salt. You can taste that small of an amount. And that's an average. So over different parts of the ocean, it'll be more or less than 3.5. But freshwater, of course, is much, much lower. All right. So we say, well, we take Canada's water for granted. Yes, but if you look at websites such as this one, you can actually see that water issues still exist. This is dated today, the day that I'm doing this lesson. And this is basically a website that shows you the different conditions of water across our country right now. So if I were to click on Alberta, the little yellow bubbles here are showing me that these are boiling advisories. So in all of these areas, there's boiling. That means that you should be boiling your water if you're going to drink it. Probably because of a bacteria. So if you boil the water, that means that it'll kill it off. So we've got, and actually there's quite a few like reservation areas that are not associated with a big town, like that would have a water treatment system. Areas that are more isolated. So water boiling issued to Beaver River Gas Bar semi-public water system. Reason not stated, but often they're stating the reasons. This one, boil order issued to Whitewood RV Park due to consecutive microbiological samples from distribution system confirming the presence of either total coliforms or E. coli. So there's a bacteria one not far from Edmonton. That's actually pretty close. Let's see if we can get another one here. We'll pick a map. Let's pick Saskatchewan, because that's my old stomping grounds. Whoa! Look at all those boiling water advisories. And then we've got one, don't consume this. So the red one shows do not consume. It's in effect for Flotton Lake due to water not meeting minimum treatment or design requirements. So that's a big deal. Don't drink water there. But this is going on now. So you've still got instances of natural outbreaks or, contamination of water samples. All right, so what kinds of things do we test water for? Lots. This is a big list. Some of these tests can be really simple, like taste the water. Does it have an aftertaste? It shouldn't. Does it smell different? It shouldn't. Does it have a color to it? It shouldn't. So these are things that are detectable just by looking at it. Now, turbidity, you can also tell just by looking at it. Is it clear? Is it cloudy? So if it's turbid looking, that would mean that it doesn't look clear. It looks kind of cloudy, and water shouldn't look cloudy. So these two first ones you can tell just by observing or smelling or tasting, using your senses. Toxicity, so if there's dangerous toxins in the water, be tested for that. Bacteria, E. coli, it'll be tested for that. Hardness, how hard the water is. It's not a touch test, it's figuring out how many minerals are in it. So there shouldn't be very high amounts of calcium or magnesium. And if there is, we would say, oh, they've got hard water. That's actually how it's referred to. And I'll show you, we have a slide talking about that itself. The pH is how acidic or basic the water is. And in a perfect situation, it wouldn't be acid or base. It would be right in the middle. It'd be nice and neutral. And then we also check it for dissolved oxygen, especially for organisms that live in the water, for aquatic environments, because they need high amounts of dissolved oxygen to survive. So that's actually, that's kind of the only good thing that we want in our water, is that one right there. And then the one at the bottom, we're back to things we don't want in the water. We don't want solids or floating or dissolved solids in our water. So it's a big list. There's lots of things that we can test water for. Let's talk about that hard water. So you might have heard this term before. Hard water refers to the amount of minerals, dissolved minerals, that water's carrying. There are some issues with it. If it's carrying a lot of calcium or magnesium, it can do things like make your skin feel really dry. So that might not seem like a huge deal, and it's not. Lots of people, actually even Edmonton's water is considered to be kind of hard water. You have to add a little more soap than you would in other places to make bubbles. Same with shampooing your hair, you might have to add. So in situations where water is considered really hard, if you add a lot of soap, it probably doesn't make a lot of bubbles. It'll also do things like leave scale buildups in devices that are boiling water. So if you see the tap here on the left, this is an example of scale buildup over time. Kind of cruddy. And on the insides of pipes, it can do the same thing and cause the pipes insides to actually sort of narrow because of that, all the buildup around there. This one on the right is, that's the inside of a kettle. So this is actually the heating element that would just be in the water, causing it to warm up. So you can see the scale sort of built up around that. And that's calcium and magnesium. So we test for that as well. And does it harm you? No. Like I have memories of being out at my grandparents' farm that they had wells and their water was harder and it didn't do anything. I don't think it did anything. I might have, maybe that does explain a lot of things. No, it doesn't, it's not harmful. Okay, bacteria in water, on the other hand, can be very harmful, and many natural sources of water contain bacteria or parasites, such as Giardia. Giardia is a parasite that can cause beaver fever. Have you ever heard of that term? It's like an intestinal response to a parasite. So you can get you can be vomiting and have diarrhea and weight loss and just make you really sick. Bacteria, kind of causes the same things. So similar responses because you're ingesting that and your intestinal system does not like that. So to get rid of organisms in water, one, we could boil it, but if you're going to go swimming in a pool, that's not a very, practical response. But we add chlorine to it. Chlorine is a chemical. It's a toxic chemical. In fact, if you add too much chlorine, you can kill larger organisms. Tiny, tiny, tiny little bits of chlorine are enough to kill bacteria. Chlorine is toxic to humans. Chlorine gas was actually the chemical warfare gas used in the early wars because it can kill people. So we do add it to our water, but like I said, only in tiny amounts. So chlorine chemicals will kill tiny microscopic living organisms. purifying water. Okay, so that's our talk on all of the things surrounding heart, like the purity. How do we actually carry it out? There's three means that your textbook talks about, 3 means we usually teach. We kind of thinned it down to 2 for this remote lesson. We'll talk about reverse osmosis and we'll talk about distillation. But I might have to talk a little bit about evaporating too, because distillation and evaporation are kind of similar. Now, reverse osmosis is basically performing osmosis in the opposite direction. So if you remember back to cells and systems, you learned that osmosis was when water moves from an area of high concentration to low. So there's more water to where there's less in concentration. With this one, this is a device that has a filter in it, and the impure water is pushed through that filter, and the holes in the filter are so small that only the water molecules or particles can go through it. Water particles are really small. So in this, this is the impure side, and you're forcing that water through this membrane, and then it'll result in the impurities staying here on the left and just the water itself being on the right. So this is purifying your water. You can buy these at Home Depot or Canadian Tire, and you can just attach them underneath your kitchen sink. They can be attached there. The only downside to this really is that, well, one, it's expensive. So it costs some money to install these. Reverse osmosis devices are usually a few $1,000s. And also it doesn't always guarantee that you're going to get rid of bacteria, because there's no heating involved here. You're not adding chemicals to it either. So that's an issue. You can't guarantee that bacteria will be killed through this method. Now, to distill something is going to boil it and then cool it. That's it. That's kind of what looks more complicated than that, but essentially that's what you're doing. So I'm going to change my color here to dark blue. Okay, so on the left, gotcha, go away. Okay, on the left is my impure sample of water. So it might have minerals in it, it might have salts in it. And when I boil that, it's going to turn the water that's in there into a gas. But those impurities are not at a temperature that they're going to also rise up with the gas. They're going to stay in that flask. They're not heated to that temperature. So their boiling points are much higher than water. Water will boil at 100 degrees and it'll turn into a gaseous vapor. So that gaseous vapor then is getting pushed down through this tube, and this tube is being cooled. It's got cold water running around the outside of it. And as that happens, as the gas moves through it, it's going to cool, and what happens to gas when it cools? It turns back into water, and it'll be the liquid form. So now it's just pure water, and all those salts are still back here in the flask. Here, let's look at a bigger example. So water is boiled to kill bacteria. Minerals are left behind as the water evaporates. Water is collected and condensed. Here's a nice picture of it as well. And this is something that I've set up at school, but obviously won't be doing this year because we have these cool little condenser tubes, this guy. So we hook it up right to a sink, and the sink is running cold water in through this tube, and cold water flows on the outside of this tube, and then there's a hose that empties right back into the sink. So it keeps this middle section really icy chilled. But through the very middle, if you look through the middle of that tube, there's a hole, and that's where this gas is being pushed through, and then it comes through the other end. So the speed isn't an issue. You don't have to do anything super fancy. You just boil it here and cool it here, and it'll arrive back here as pure water. All the impurities are left in the flask. So evaporation is pretty similar to this, except you're not boiling it. Like, for example, to evaporate, you know that if you evaporate water, it just rises into the air as a gas. And over time, let's say if I left a glass in the windowsill and I came back 2 weeks later, I'd probably notice that that glass is less full of water. So it's actually gone down a little bit because those water molecules have moved into the air. And eventually, if I left it there for a month, that cup will be empty. So it'll just be sitting there, and you might see like crusty stuff around the bottom, stuff that didn't evaporate into the air. So you could actually use evaporation and condensing in a really similar way, even more simple. So evaporation, if you look up anything like, oh, they were stranded in the desert and all they had was a plastic bag, how could they get water from that? All you had was an empty plastic bag. So if you were able to somehow trap some air in that bag by scooping some air and letting the sun just heat that bag, and then at nighttime when it chills out, it's going to cool and it's going to condense and fill the inside layer of that bag with wet dew droplets. Those dew droplets are going to be pure water. Kind of bizarre, but it's a really simplified way. The only thing is that evaporation isn't always going to get rid of your bacteria because you're not superheating it. You're just allowing the sun to warm the air and allow that to cool on the bag. So there's no boiling. So the bacteria still could be an issue. Anyhow, at the end of this lesson, I'm going to skip back here on the other Google presentation that's attached. I really encourage you to have a look at this TED Talk. It's awesome, and there are some good clips on your last lesson as well. So I hope you're playing those videos, because that's one thing that we can't do from here is we can't play them. Okay, so quick recap. We looked at water quality. What is it? We looked at what could be in your water. We looked at what would we test water for, that big long list of things we tested. What is hard water? What is salinity referred to? Salinity. Why do we use chlorine in our water? It's so toxic. So those are kind of the basics. And then finally, how do we purify water? What is the difference between reverse osmosis and distillation? So this final page, once you've completed this lesson, open up and watch the review, because the review is just going to give you like the fastest recap of the biggest ideas that we learned in these last 2 lessons. And then we're giving you a 1.0 assessment. So go into your homeroom classroom and complete that Google form. Okay, that's your topic 1 assessment, topic 1 test, if you will. You also have 2 terms from this lesson now on your vocab list that you can fill in. That's water quality and hard water. And that is it. Let's have a look. Okay, so looking ahead, same idea. Your next steps, I just went over them. Watch the review, do your assessment. On Wednesday, we're still in the planning stages. We're trying to figure out some way that you can assess your water quality at home. So we'll have maybe a little activity for you to carry out and see if you can find something about the quality of your water at home. So stay tuned. All right, keep working hard. Come to the video chats if you have questions. Yeah, keep in touch. Keep emailing us if you have questions. We try to get back to them as soon as we can, same day, hopefully. And that's it. Stay safe, stay healthy, and good luck.